The May 2018 AS paper question 7. In triangle ABC, side AB has a side 10 centimetres and AC has a length 5 centimetres. Angle BAC is equal to theta, where theta is measured in degrees. The area of the triangle ABC is 15 centimetres squared. Find the two possible values of cos theta. So the first thing I'm going to do is I'm just going to give a quick sketch out of the triangle so I've got an idea of what I'm working with. So it could be looking like anything we want. So I've got A, B and C. And so AB is going to be 10 centimetres, AC is 5 centimetres, and the angle there is theta. So what we know is that if we are saying that the area is 15 centimetres, the area of a triangle is a half AB sine C. And so we've got a half. A I'm going to call 10, B I'm going to call 5 sine theta, and that is equal to 15 centimetres squared. So 10 5s are 50, a half of that is 25, so we've got 25 sine theta is equal to 15. Sine theta is equal to 15 over 25, which is going to simplify to be 3/5. Now, the issue is that we've got sine theta here and we're asked to find the possible values of cos theta. So what I'm going to do is I'm going to have a look at how sine theta might work in a triangle. So if I just make up a right angle triangle there with an angle theta, we know that sine theta is the opposite over the hypotenuse. So if it's opposite over hypotenuse, we can have the opposite and we can have the hypotenuse there. So the opposite is 3, the hypotenuse is 5. Using Pythagoras' theorem, we can say that 5 squared minus 3 squared is equal to 25 minus 9, which is 16. And so the square root of 16 is 4, leaving us with that missing length of 4. So if sine theta is the opposite over the hypotenuse, cos theta must be the adjacent over the hypotenuse. Now, it says two possible values and we've only got one possible value here. Now, the reason for that is because we're in a triangle, that angle could be somewhere between 0 and 180 degrees. Okay, somewhere in between those two angles. So what we've got, well, it can't technically be 0 or 180, so I'll just get rid of that, but between 0 and 180. So if we think about it, that angle theta could be, in our cast diagram, anywhere in these top two sections. Now, if it's in here, then we've got a positive cos theta and it's 4/5. However, if it's in here, we're going to have a negative cos theta. So cos theta could be plus or minus 4/5. It could be either one. Now we can have a look at part B. Given that BC is the longest side of the triangle, find the exact length of BC. Now, this is the key part. The key part of the question is that we are told that it is the longest side of the triangle. If it's the longest side of the triangle, that means that our angle must be greater than 90 degrees. And so what we know is that cos theta has got to be minus 4/5. Because if it's greater than 90 degrees, it's going to be in this quadrant here where only sine is positive and cos is going to be negative. So if we want to find the exact length of BC, what we've got is we've got our triangle. So back from previously, I'll just sketch out here, you've got 10, you've got theta, and you've got 5, and we can use the cosine rule to find our missing length there. So here, a squared is equal to b squared add c squared minus 2bc cos a. We've got a, b, and c as our lengths. Sorry, wrong way round at all. We've got B, C, and A as our lengths. So to write this out, we're going to have x squared is equal to 10 squared add 5 squared minus 2, lots of 10, lots of 5, lots of cos theta. Just to keep that separate. So part of this is fairly straightforward. X squared is equal to 100, add 25, minus 2 times 10 is 20, times 5 is going to be 100. And we know that cos theta is minus 4/5. So therefore we've got that x squared is going to be 205 and x is the root of 205 as our final answer.